Absorption, like we said, refers to how a drug enters the body and passes into all your body fluids and into your tissues. And absorption takes place through various semi-permeable membranes, whether they're in the stomach or in the kidneys or passing into the capillaries. But they take place by diffusion, filtration, and osmosis. And you've learned about these in, oh my goodness, probably grade school science, high school science, also in anatomy and physiology, and we can't get away from it. Here it is again. Diffusion refers to something that is very highly concentrated to a place where there is a lower concentration, and this sort of happens naturally. If I'm standing in the corner of the classroom and I spray a bunch of perfume on myself, it's in one corner, very concentrated, but it isn't in any other areas of the classroom. And so those molecules are going to disperse, and they like to disperse evenly. So after a minute or so, somebody at the other end of the classroom is going to be able to smell it because of the diffusion of those molecules as things go spread out a little bit and arrange themselves more evenly. One example of how this works in the body is oxygen being taken into the lungs, into the alveoli. All the alveoli are surrounded by capillaries. When the alveoli have a lot of oxygen, the capillaries surrounding them don't have as much oxygen. They have carbon dioxide. So the oxygen wants to move out of the alveoli into the capillaries, while the carbon dioxide wants to move out of the capillaries into the alveoli, so they even themselves out, and then we can breathe the carbon dioxide out into the air while oxygen is carried all over our body. Works out very nicely. Then there's filtration, and filtration and osmosis can really be demonstrated more by either the kidneys or kidney dialysis, because those have a very obvious filter that we can see. Filtration prevents certain molecules from coming in while it allows other things in, and it does that through that membrane. And we see this in the case of dialysis. You've got a filter. There are certain things that have to be allowed to stay in the blood, potassium and sodium and all the other minerals that are needed, while extra needs to be taken out. Ordinarily our kidneys would do this, but in dialysis we got that strong membrane all through the tubing that is going to return to the body what is needed and keep out what isn't needed. With osmosis, you're going from that membrane from a less dense solution to a more dense solution. And we see this when solid materials are moved by a fluid mixture. So we see kidneys filter out harmful waste. You've got all kinds of things filtering through the glomeruli of the kidneys, and harmful larger molecules, harmful things tend to have larger molecules, so they're kept out of the kidneys so they can be excreted in urine, but once they're but the helpful molecules, once the liver has broken them down and put them into a form the body can use, then those can be returned to circulation. So we see that all of our body systems are going to absorb medications or other substances, food, whatever else we take in one of these three ways, depending on what it is. So lungs and oxygen and carbon dioxide with diffusion, and then filtration and osmosis is very well demonstrated by the action of the kidneys, or in the absence of that, by the action of dialysis. Distribution, the drugs, molecules, after they're broken down, are carried throughout the body, usually in the bloodstream, but also in the lymph system to a certain extent. We have lymph fluid that circulates, and many molecules are carried in that. There are certain barriers that come up sometimes as a form of protection. The smaller the passage, the smaller the molecules have to be for substances to go through. And two of these protective barriers are found in the brain. We have a blood-brain barrier, and we have the placenta, which allows oxygen and nutrients to go from the mom to the fetus, but it also keeps out some substances that could be considered harmful. Some of the chemicals, as they go into the body, they have an affinity for protein, and they're going to bind to proteins, especially albumin, which is the most common circulating protein in the bloodstream. Other chemicals are attracted to tissues besides the receptor sites, and they absorb in that way. If somebody will store a chemical in adipose tissue, it stays in the body longer than if it is water soluble and just kind of goes in a straightforward way through the GI tract to the liver and then to the kidneys. Some other areas where you can find drug metabolites are bones, muscles, and organs. Small amounts can collect in those areas. This is, and you can look at it a little bit more clearly on your own slide, but this is an example of the blood-brain barrier. And as you can see, as you go higher up into the brain, the little areas get smaller. And so the brain helps filter out a lot of harmful substances which tend to have larger molecules. However, it will let in things with smaller molecules, for instance, oxygen. The brain has to have oxygen, it has to have glucose. Glucose is really its only food, and these have small molecules and can readily get into the brain. On the other hand, alcohol also has very small molecules. Remember how I talked about that, how it's a good carrier because the molecules are small enough for it to absorb rapidly. All you have to do is have a drink on an empty stomach to know how fast it absorbs. And unfortunately, alcohol can get into the brain pretty readily too, especially if you haven't had anything to eat. But larger molecules, which tend to be toxic, are usually filtered out of the brain and can't get in. And that's mostly a good thing, although it does sort of defeat us when it comes to brain tumors, because most chemotherapy won't travel across the blood-brain barrier. So that's why when someone has a brain tumor, they either need surgery or radiation to take care of it. Chemo usually doesn't work for it because it'll be prevented from getting into the brain. It's carried through the bloodstream, but the molecules are too big to go into the smaller passages in the brain. The placental barrier is also similar. With the placenta, you've got a maternal side. It's attached to the inside of the mom's uterus, and then you have the fetal side, which faces the fetus. And there are ways that things can absorb through the cells, and then there are ways that things can absorb between the cells of the placenta. And most of the time, it's going to readily let in oxygen. It's going to readily let in vitamins and minerals and other nutrients, but a lot of larger particles that may be toxic are thankfully prevented from getting through the placenta because the little openings are so small. Once again, alcohol goes pretty readily through the placenta because the little intracellular spaces and cellular spaces are very small, and that's why women are warned to avoid alcohol during pregnancy as much as possible because it readily passes. Whereas other things do, but not quite as easily as the things that are supposed to be in there.